Hi everyone, welcome to Legacy to Modern in 3 Steps with Couchbase. I'm Matt Groves and I'll be taking you through the 3 steps today. So let's go ahead and get started. First, we want to make sure we're on the same page in terms of your goals with migrating over. Do you have a use case that can benefit from a modern database like Couchbase? Something like a Customer 360, a session store, or user profile, catalog, maybe some large-scale fintech, and make sure you have a use case that fits with the modern database. The next thing, you're going to want to get the data that you need for that use case. It may be existing currently in a legacy system, like an Oracle or SQL Server or DB2 or so on, and you may only need a portion of that data for your new application efforts. It may not need everything. You might in some cases. And the third thing is we're going to actually modify the application, switch the application to use Couchbase, or possibly spin out a portion of functionality into a microservice for just that portion you want to modernize. And if you're starting a brand new application, the same thing applies there as well. And finally, once we get the data into Couchbase, we're going to look at some ways we can optimize it. If it's relational style data to begin with, we can make some changes to it in order to take advantage of Couchbase, improve performance, and just with some few simple model changes, we can do that. The 3 steps we're going to go through today are we're going to map our data over from relational database, just sort of a copy and paste to an extent. We're going to copy the structure and the data itself, as well as affiliated data. Then we're going to look at the ways we can shift the application code over, and actually with Couchbase, this is going to be much easier. You're going to have a nice head start if you decide to use Couchbase for your modern apps. And then finally, once the data is moved over, we'll look at some ways we can optimize the data through modeling and other techniques in order to improve performance and hit your performance goals. So the first thing we're going to do is we're going to map data over from a relational database. And why are we doing this now? The features in Couchbase 7 make it easier than ever, and that's the main driver to starting to move those use cases over from relational to a modern database. The features I want to focus on are specifically scopes and collections. These provide organizational building blocks akin to schemas and tables in the relational world, and you can match those up in Couchbase pretty straightforward. Asset transactions have been in Couchbase since version 6, but they're expanding even further in version 7, and this means you can fall back to relational style modeling when you need to. And you hopefully want to avoid that as much as possible. We'll talk about that later, but it is there when you need it. And finally, Nickel has been around long before Couchbase 7, but it continues to mature, including richer functionality like user-defined functions, UDFs, and it even has a begin, commit, rollback itself in Nickel language we can use for transactions. So you might ask then, is Couchbase just a relational database now? Have we just reinvented the relational wheel? And I would say that Couchbase has become a fusion of the best of both worlds between relational and non-relational databases. So you can do relational style things now, yes, but the core focus on Couchbase still includes all the things listed here that it's always had. And so Couchbase, our goal is not to reinvent the wheel, but to push the boundaries and support the needs of your modern application development through our core strengths of being a distributed database, being highly available, still having a flexible data schema, and still having a memory-first built-in cache layer. So I went ahead and put together a SQL-to-Couchbase Dictionary, like a translation guide, just to kind of give you a mapping, if you're familiar with relational databases, and how that maps to a very similar concept in Couchbase. And then it's not just, like I said, we're not just reinventing a relational database. We're actually providing more features and functionality on top of that. So you get those as well, and I've added those in the notes column there. So if you're coming from a relational background, you have a database server, and the equivalent of that in Couchbase is a cluster. So instead of a single machine, you now have multiple machines that make up a distributed cluster that communicate with each other over a network, as if they were one unit, the cluster. And so just by switching to Couchbase and getting a cluster database, we're adding scalability and high availability. So multiple machines that can process more operations, and high availability. If one of those machines happens to have a hard drive that fails or something, the rest of the machines will pick up the slack and still keep the cluster available. The next level down is, in the relational world, a database. And the equivalent of that is Couchbase is like a bucket. But again, at the bucket level, you can define replication settings. So you can say, I want a replica of all the data in here, 1, 2, or 3 backup copies that get distributed amongst the whole cluster. And you can also specify the amount of caching you want at the bucket level. So it's a built-in caching system. No need to bring in a separate piece of software in order to add caching to your database. The next level down in relational is schema. This may not be something you're that familiar with, especially if your databases, by default, typically you'll put data into one schema, but you can have multiple schemas in relational databases. And the same thing in Couchbase, you can now have scopes, which is at the same level of organization. And if you're not familiar with this, maybe you've seen DBO, for instance, in the SQL Server world. It's kind of the default schema. Some people just put everything into the default schema, and that's totally fine. You can do the same thing with Couchbase using the _ default scope, but you can also use scope as a way to organize your data by microservice or multi-tenancy. The next level down is table. That's the one everyone's familiar with from the relational world. The equivalent level in Couchbase is called a collection. So a scope can contain multiple collections. And what we're gaining here is now flexibility. So you don't have to define a Couchbase collection up front with all the different column names and constraints and everything, all the data types up front. So you gain some flexibility when you move from a relational database to a Couchbase collection. Inside of a relational table are one or more rows of data. The equivalent of that in Couchbase is a document. So a collection has one or more documents inside of it. In Couchbase, though, now we're storing data as JSON. So it's a richer format that allows for nesting and arrays of objects and so on. So you can represent very complex pieces of data and not just a flat row of data like a relational database. At the query level in a relational database, you'll have a language like T-SQL, Transact SQL, or even PL SQL. That's the implementation of SQL for that relational database. In Couchbase, what we have is called Nickel. It's an implementation of SQL for JSON data. But unlike other databases, it's a full SQL implementation with everything you'd expect from SQL. So that includes select, join, commit, rollback, group by, insert, CTEs. Everything you'd expect from SQL is there in JSON data. So this isn't just a small subset. In relational databases, you can optionally have a primary key for each table. It's optional, but most databases do use a primary key. In Couchbase, every piece of data has to have a document key. So very similar concepts there. And of course, in relational databases, you have indexes that help your queries be more performant. And the same goes for Couchbase as well. You can create indexes, a wide variety of flexible indexes to make sure your queries are efficient. So with that translation guide in mind, I'm working on a project called SQL Server to Couchbase. This is a .NET library that helps developers move from SQL Server to Couchbase specifically. Now, even if you don't use .NET or SQL Server, the same principles are still going to apply to any relational database. And in fact, there are some other tools that take a very similar approach to what I'm doing. Anything from a fully commercially supported tool like GlueSync, which is built by Couchbase partners Molo17. And there's open source projects like mine and like Couchgress. It's just a set of tools and libraries and different approaches to move the data over from a relational database. Couchgress happens to be Postgres and mine is SQL Server, but the approaches are very similar. And all the way down to a DIY set of scripts, like a Python script. It's like a bare bones script-based approach. It allows you to do a lot of customization if you want to. You can import CSV into Couchbase via the UI. So the whole range of options here, from a fully integrated commercial solution, which by the way is a real-time sync, not just a one-time, all the way down to the bare bones do-it-yourself script. These are all options that are available for you from moving from relational to Couchbase. This is a view of a sample relational database. This happens to be SQL Server, and I've written that utility to convert and copy from SQL Server to Couchbase. It's going to copy the structure as well. So for instance, the tables in SQL Server, they become collections in Couchbase. And rows of data in those tables become JSON documents in Couchbase, and so on. And so you can see here on the left, you've got the database, and then you've got the schemas like human resources and person, the tables within those, And on the right side, I've got a SQL query, and that returns data within the person table. Over in Couchbase, the end result kind of looks like this. It's going to be very similar. You have the rich structure of scopes that correspond to the schemas that were in SQL Server. Each scope has multiple collections that correspond to the tables. And then inside those tables, you can see on the right side of the screen there, we've got the JSON documents. What's not pictured here are the indexes. Those are also copied over field for field, just like they were in SQL Server. So you can still execute SQL queries against this data, just like you could in SQL Server. The data is JSON. It's going to start out very uniform, like a relational database, but you can introduce flexible data as you need to. Okay, so we've got the data moved over. So speaking of SQL and NoSQL, we're going to move on to step 2. And this is moving the database over is an important step, of course, but there's also the application code that connects, reads, and writes from the database. So if you're spinning off a new service, a brand new service, no problem. You don't have to necessarily worry about shifting an application over. But if you're spinning off part or all of an application, you'll need to make changes to the parts that use relational databases. One thing that sets Couchbase apart from other document databases is that Couchbase has supported SQL for many years. So if you're already using SQL queries in your applications, this is not going to change that much. And that's going to make the transition smoother. A lot of databases claim a SQL-like language, but NoSQL is on a whole other level in terms of the capabilities. So for instance, this query here is actually from an official Microsoft documentation example about Transact SQL. That's the SQL Server implementation of the SQL query language. And this query returns all employees and the cities that they live in. This is a non-trivial example of a SQL query. There's multiple joins. There's a subquery in there. Ordering is happening at the bottom. There's multiple tables, multiple schemas involved, string functions, and concatenation. Now, I'm sure you've worked with queries that are a lot more complex than this, but this is a pretty significant query, and it fits on a slide, which is why I'm using this as an example here. This is the same query converted over for use in Couchbase using the NoSQL query language. And this query returns the exact same results as the other one, assuming we've copied the data over. There is a slight difference in syntax here, and I'm going to give you a second here to see if you can spot what it is. If you blinked, you might have missed it when I changed slides there. But the only thing that's different is the concatenation operator. So for Couchbase, it's double pipe instead of the plus symbol. You can see in that very first line when we're concatenating the first name, last name, and a space in between. Now, it's not always going to be this easy, of course, but you get a pretty good head start towards modernization if you use Couchbase. And you're using a language that most developers in your organization already know, and that's SQL, SQL. The next thing we want to talk about is ACID transactions. In the relational world, these are vital. This is how a transaction looks in C# when using a tool called Entity Framework. And again, you don't have to know all the details of that. I've left out the actual data manipulation code in here. So again, this fits on the slide. We just want to identify the 3 main steps of this. So to use a transaction from an application, we need to begin. We need to start a transaction. Every data operation in this transaction becomes part of an all or nothing operation. The second step is a commit. We're telling the database the transaction is done. So any of the data changes we've made, go ahead and now commit them and consider this operation complete. And then worst case, of course, is a rollback. If something goes wrong, there's an exception or some sort of condition, we can then tell the database, roll back this transaction to the beginning as if it had never happened. So we have to have those 3 different things in order to perform transactions in our application. Here's how a transaction looks in C# when using Couchbase. So again, I've left out the data manipulation code so it fits on the slide, but there are the same 3 parts. So we're going to start by creating a transactions object. Now there are some different settings here to think about because we're dealing with a distributed database, which is multiple machines over a network, and there's some challenges with that. But there are sensible defaults when you're using the Couchbase SDKs. I'm using .NET in this case, but it's available for other SDKs like Java and C and so on. Second part of this is a commit. So now notice in C#, the transaction actually uses a lambda function. an anonymous function. Everything within that lambda is in the transaction automatically. And this is true in Java as well, by the way. The commit doesn't have to be explicit in this case. It just happens when the lambda ends. So when the lambda ends, we know when we're executing that lambda, it comes to the end of it. After that, we'll go ahead and commit. And that's just implied. The rollback is also implied. So if there's an exception thrown unhandled within the transaction, then it will assume that something went wrong and it will go ahead and cause a rollback to happen. So it's also implied. Now you can execute commits and rollbacks explicitly if you need to. So for some more complex logic scenarios, you can absolutely do that. But it's just kind of an implied part of the transaction here. All right. So let's go on to optimize, the last step. And really what we're talking about here is the main thing we'll talk about is consolidation. So we started with moving data from a relational database into Couchbase. And that data is still spread out in Couchbase as if it were relational data. It's relational style data. Now that's fine, it'll work, but it does often require us using lots of joins to bring those pieces together. And it requires oftentimes using an ACID transaction in order to make changes to multiple pieces of data as if they were one atomic unit. So one of the things we can do with Couchbase that will improve performance is a modeling change, and we can just consolidate those pieces of data into a single piece of data. Let me show you what I mean. So let's say we have a many-to-one relationship in our relational style data. In this case, we have a person record, and that person can have one or more email addresses. In this case, just the one, but they could have 2 or 3 or 4, whatever. So when I copy the data from relational to Couchbase, it stays in this relational style format. So person is a single document, and person can have multiple email addresses, so multiple email address documents. And I don't have to keep it this way, though. In fact, keeping it this way can be a detriment to performance. So because now I need to use a join to join that person together with their email addresses if I want to return both those things together. And I may have to use an ACID transaction. If the user wants to update their name and email address at the same time, they'll need a transaction to do that. So you can still do it this way. We have ACID, we have join, you can do it. But you may want to consolidate because that can help you meet your performance goals. So in my utility that I wrote, you can specify which tables should be combined. And the end result would look like this. So now we have a single consolidated person document. You no longer have to use a join. And you no longer have to even use a nickel for that matter. We'll talk about that in a second. But it's now a single piece of data that we can retrieve. And you don't need an ACID transaction to update this. You can just have one operation that can update any piece of data or multiple pieces of data in that document. So if you're working on a use case with a user profile that has millions of users, let's say, hundreds of thousands of users even, and they often update their profile, there's a lot more to a user profile than just name and email address typically, right? But if you've done this modeling change, you've just improved performance with one really simple data model refactor. Another approach is a one-to-one relationship in a relational database. So an example might be here, phone number has a phone number type. And it kind of works the same way in relational. There is data for the phone number in one row and data for the phone number type in a different table in a different row. And again, with that utility that I wrote, you can specify which collections get combined. So this is how they would look like if I combine them into one single document. Now is a single phone number record is the end result, and the type information is embedded into that. So there's no need to join to get that information anymore. Now, this kind of approach, if it's a one-to-one, you should think carefully about this because in the long run, if you need to add, modify, or delete phone number types, you'll need to update all the phone records themselves because now it's embedded in them. But maybe that happens so rarely that it's worth the performance trade-off. You know, it's very often you're going to read a person's phone number and their phone number type. It's not as often you're going to add a separate phone number type to the system. We may have cell, home, and office. If we need to add a fourth type, maybe that happens every year or something, and that's worth the trade-off. And finally, I want to talk about using the key value API in Couchbase. So with relational databases, SQL is the only way you can interact with data. Couchbase, however, it can use SQL, of course, but it can also function as a key value database. And using the key value lookup is always going to be the fastest way to interact with data, to retrieve and write data in Couchbase, a single piece of data. So if your application has a SQL query that's looking up a single piece of data by its ID, like shown here, replacing that with a key value lookup is going to improve performance. It's going to reduce latency, and it's going to reduce pressure on the query service because we're just looking it up by the key value directly from the data service. Whereas if we go through a query, it has to go through the query service, perhaps the index service, and then onto the data service. So we're reducing some overhead in this process. This is a C# example on the right, but of course, similar APIs are available for all the Couchbase supported SDKs, Java, Node, PHP, Python, and so on. And just once again, you can keep the version on the left if you want, but the version on the right is just going to be better in general. All right, that's all I wanted to cover today. Thank you very much for coming to the session. If you want to check out this project, I'm very much interested in your feedback, criticisms, suggestions. You can check it out on GitHub /mgrove/SQL Server to Couchbase. Thank you very much, and I hope you enjoy the rest of Couchbase Connect Online.